Hello everyone and welcome back. This is our first video lecture. This will be the lecture where we cover the derivative definition. If you were in the in the physical classroom, the last class before the hurricane, then I actually gave this definition right at the end of class, but I feel like we need to go back and start from there because I'm sure that a lot of people have been through a lot since then. So first of all, let's just look here. We've got the definition of the derivative. We've got a function f of x. And so it's being defined in terms of this limit here. And so when you look at this limit, think of the h as something that's variable. So this is something that can vary. And then think of the x as being fixed. And that makes sense because we're taking the limit with respect to h as h goes to 0. And so we define the derivative this way for any x value, for any real number x. And remember this little e symbol. Whoops, that's the wrong thing. This little e symbol is an element of. And so for any x, an element of the reals means for any real number x for which that limit exists. So we define it to be this value if that limit exists at that particular x value. All right, so before we continue looking at the picture, I want to flip over and let's just have a look at one of the links in the document that I put out there on Moodle. I think I talked about that in the introductory video that I put out there. Okay, so let's just flip over to Moodle real quick. And this will just take a second. Let me just, yeah, there we go. Okay. And so we'll go to our class. And this is it, this graphical illustration links. And like it says here, thank you to Dr. Gamble, Heather Gamble. She put this together. And I actually added this one. So let's just have a quick look at that. So you can see that in this case, the derivative, we're looking at the derivative at 1. And so you can see from this, this GIF that the secant line, which is the red line, is being drawn for smaller and smaller and smaller values of h. And so you can see that that secant line tends toward the tangent line, and that's what we're interested in here, the tangent line at the point on the blue curve when x is 1. Okay, so now let's go back to our, my iPad is not, there we go. It was not cooperating. Okay, so now we'll look at the picture that I put on here. It's not as well as what we saw before, but hopefully it'll get the job done. So just an interpretation of that definition. So here again, x, we're going to treat that as fixed. And then we're also looking at x plus h. And h here is any real number. So it could be negative, but we'll just think of it as positive. And so we have x plus h. And then let's see, if we just zoom in, this sort of gray curve here is, so this is our original curve. And so so we can think of that as our y equals f of x. And so we're going to look at the point on the curve at x, so x comma f of x. And then also we're going to look at the point on the curve when we're at x plus h. So that would be x plus h would be the x coordinate, and then f of x plus h is the y coordinate. And so this orange line is the secant line, and so that's the line that joins those 2 points. And for small values of h, the slope of the secant line is really close to the slope of the tangent line. But in order to get the actual slope of the tangent line, we have to look at the limit as that increment, that h value goes to 0. Okay, so I have that actually written here. So you can see that the slope of the secant line is, well, it's just the y2 minus y1 over x2 minus x1. You may remember that formula for the slope of the line given 2 points on the line. And so it's just the y2 is the f of x plus h, so this would be like our y2, and minus our y1, which is the f of x, and then over x2 minus x1. Okay, and so that's how we get that, this, what's called the difference quotient. That's how we get that. And that's the expression that represents the slope of the secant line. But remember, our objective here is to determine the slope of that tangent line, the slope of the red line in this case. And so to get the slope of that tangent line, we're going to take the limit of the slope of the secant line as h goes to 0, and that is f prime of x, right? So if we go back to the definition, then the limit of that difference quotient as h goes to 0, that's exactly how we defined f prime of x, right there.